Hello everyone. Here we have an implant case where the abutments are long and entering into the mesh of the antagonist teeth, where the analog sleeves have cut through the contact areas of canine and molar, and where the two abutments do not share a path of insertion, and the doctor wants the two crowns to be as a single piece, not separate crowns. With the power of Blender and Blenderfordental, we can solve this problem. So here is the situation before. The problem of the analog sleeve cutting through the contact areas of the adjacent teeth. First, I'm going to select one of the sleeves, select all the vertices on the periphery, make duplicate from it, and then separate it from the sleeve analog. Now I'm going to hide the sleeve analog, then select the circle which we have created from the analog sleeve. We're going to fill the surface and then move towards the scan body by extrusion in the z-axis. Then we are going to check the face orientation, and it's outside, which is correct. Now we are going to do a clipping board by Alt-B and see the contact area. Now as you can see that the original analog sleeve is going to cut through the contact area. That's why we are going to select the analog sleeve that we have created and then select one of the edges with a proportional editing enabled, and then we are going to move this area away from the contact. We are going to do the same for the other analog sleeve. Okay, now we are going to join the two cutters, and then while selecting the mesh as the last object, we are going to activate Bool tool and do a difference boolean. Now it has cut through the mesh. There is a little bit of the mesh separated from the mesh of the scan. We can select it and then delete it. We can push these faces a little bit downwards so we can see the analog. Of course, we have to disable the proportional editing. And now we can smoothen. Of course, when we enter into the sculpt tool, we can see that the Blenderfordental Modules have masked this area. We can remove the mask by mask, clear mask, and then we are going to smoothen these contact areas. We have solved the contact area problem. Now I have imported the abutment that we are going to use. Unfortunately, some libraries do not include the abutment sleeve, so we have to create one for ourselves here. We make a duplicate from this abutment, then isolate, go into edit mode, enable the transparent mode, select all abutment mesh under the margin, and then delete vertices. Select all these vertices and then dissolve them. After creating our custom sleeve, we have to do some adjustments. We have to select the sleeve, go to modifiers, solidify, and then add the 100 micron of offset, and then only rim. We apply it, then remove bottom vertices, and to make a better fit, we can select the bottom vertices and then Control plus in the numpad to select margin. We can name this as margin. Then we apply another modifier called shrink wrap, and we use the abutment as the target, and only the margin that is going to have this effect applied. And then we can put like 20 micron, like an offset. So in this area, it's not touching. Then we apply. Now we can join the abutment with the abutment sleeve, rotate the abutment, and then make a copy from it. And then we proceed with the normal implant procedure. Select the analog as a destination, and then match position. Same here as well. Another problem is that the abutments are too long and entering into the mesh of the antagonist. To solve that, we have select the abutment sleeve, select the face, duplicate it, separate it from the abutment sleeve. While selecting the face we have created, we are going to extrude and scale while in edit mode. Then we are going to extrude into Z-axis. And here we can put the amount of reduction we want to do. So here we're going to 2.5 and then check for the face. It's not the right faces, so we are going to change it to the outside face. That's correct. Before applying the Boolean, we have to join the abutment and the abutment sleeve and then apply Boolean using the modifiers. Boolean difference and then select the cutter. The advantage of using Boolean modifier is that it is non-destructive, which means you can move the cutter and assess the situation. Then we apply the modifier. Same again, we have to separate the abutment from the abutment sleeve, but not by loose parts because they were cut as a one piece by material. Now, if we did a cross section here, you will see we have a little problem. While the axial offset is intact, the occlusal offset is gone. Now we have to recreate the offset, and how we do that? By selecting the abutment sleeve, select the top face, and then move it a little bit for 100 micron. Now we have regained our occlusal offset. We are going to do the same for the other abutment. So after we have reduced the abutment height for the second abutment, we now have a problem that still, after all this, there is no common path of insertion for the abutment. Now we are going to go to the Blockout module, and before proceeding with the Blockout module, we are going to select both of them, duplicate them, and then join the duplicates, and then proceed with the Blockout module. We don't need any minimum offset, and then we could add a small voxel remesh for details, and then we survey both abutments. To have an easier surveying, we are going to enable transparent mode, and then by using the gizmo here, we are going to see if we can find a path of insertion without making the blockouts outside the margin of the abutment. And you can press shift while dragging and moving for final movement. Both of the margins are intact, and then we create passive model. The reason why we duplicated the original sleeves, that we are going to use them as cutters. We are going to enable original models. So we're going to select them, separate them, select one of them, select the outermost vertices, duplicate it, separate it from the main one, hide the sleeve. We are going to use this circle again as a cutter. While in edit mode, extrude scale, extrude in the Z-axis. We don't have to go to the whole length. And then we are going to check for the face orientation. We need to flip it. Now we are going to select this cutter first, and then the blocked abutment sleeve. Then using the bool tool, difference, go into edit mode. While the faces are selected, remove the faces, and then select the other mesh and remove it. Now we have a sleeve with the margin intact. We are going to do the same for the other abutment sleeve. After doing the same for the other abutment, you can appreciate that the difference between the blocked out sleeve and the original sleeve. As you can see here, all this was an undercut area which has been blocked out. The same for the second abutment, but from the other side, so that we can have a similar path of insertion. Before going to crown fabrication, we have to separate the sleeves. To take notice of the origin. Now the origin has been changed, and we have to regain the origin as before, so the scripts can work well. To regain the origin of these blocked out abutment sleeves, we have to select the abutment, and then Shift S, move the cursor to selected, then select the sleeve, and then right click, set origin to 3D cursor. We are going to do the same for the other. Also, before crown fabrication, we have to select both of the abutment sleeves, go into edit mode, check for the face orientation, and we need to flip it. We select all and then flip it. Now it's in the right orientation. Now we are ready for doing crowns. Select one of the sleeves and then proceed with implant crowns. As you can see, even the hole cutter is in its place. Now with the second abutment. And now we are ready for crown fabrication.